Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. SN2 reactivity order, methyl primary, secondary, tertiary, essentially 0. Additionally, special steric environments, bridgehead, aryl, neopentyl, can completely prevent SN2 even at formally primary or secondary centers. Step-by-step analysis. A. 1-bromobutane, primary alkyl halide, Br at C1. No branching adjacent to the reaction site. SN2 proceeds readily. Yes. B. 1-chlorobutane, primary alkyl halide, Cl at C1. Similar to A, chloride is a leaving group and the carbon is unhindered primary. SN2 proceeds at a reasonable rate. Yes. C. 2-bromobutane, secondary alkyl halide, Br at C2. Secondary carbons are more hindered than primary, but SN2 can still occur at a reasonable rate with a good nucleophile. Yes. D. 2-chlorobutane, secondary alkyl halide, Cl at C2. Same reasoning as C. SN2 occurs at a reasonable rate. Yes. E. 2-chloro-2-methylpropane, tert-butyl chloride, tertiary alkyl halide. The carbon-bearing Cl has 3 methyl groups, creating severe steric hindrance. Backside attack is essentially impossible. SN2 does not occur at a reasonable rate. No. F. Bromocyclohexane, secondary cyclic alkyl halide. The ring carbon-bearing Br is secondary. Although cyclic, SN2 can still occur at secondary cyclic carbons. The ring does not fully block backside attack for cyclohexyl. Yes. G. Bromobenzene, aryl halide. The CBr bond is part of the aromatic ring. The carbon is sp2 hybridase. Backside attack is geometrically impossible for SN2. The ring blocks the back lobe. No. H. Benzyl bromide, primary benzylic carbon, pH, CH2Br. The carbon is primary and unhindered. In fact, benzylic position is activated toward SN2 due to partial stabilization in the transition state. Yes. I. 1-bromo-2,2-dimethylpropane, neopentyl bromide. Although the carbon-bearing Br is formally primary, Br, CH2, the adjacent carbon is quaternary C, CH3, 3, creating severe beta-branching steric hindrance. The bulky tert-butyl group blocks backside approach. SN2 is extremely slow. No. J. Bicyclo compound, norbornene-type bridgehead bromide. The Br is at the bridgehead carbon of the bicyclic system. Bridgehead carbons cannot undergo backside attack because the ring system physically prevents the nucleophile from approaching from the back. Brett's rule context for SN2. No. K. 1-bromotryptizine, tryptizine is a highly rigid tricyclic framework. The Br is at the bridgehead carbon surrounded by 3 aromatic rings. This is the most sterically congested bridgehead possible. Backside attack is completely blocked. No. Summary. Yes, SN2 at reasonable rate. A. Primary. B. Primary. C. Secondary. D. Secondary. F. Secondary cyclic. H. Primary benzylic. No, SN2 not at reasonable rate. E. Tertiary. G. Aryl. I. Neopentyl, primary but beta hindered. J. Bridgehead bicyclic. K. Bridgehead tryptizine. Therefore, the correct answer is yes. A, B, C, D, F, H, no E, G, I, J, K. Therefore, the correct matching is no matches E, G, I, J, K, yes matches A, B, C, D, F, H.